Hi and welcome to my presentation of Lab 5, where we were supposed to solve the maze using Q-learning. And well, Lab 5 is much as Lab 4, so much of the code is the same. So I will not talk so much about that. We make the maze in exactly the same way. We have the maze class, which also is I think exactly the same as in the GA. We have the minion class, which also is much the same with moving the minion and such. The big difference here is where I update the policy for the minion. So how I do it here is, well, in short, the minion backtracks its movement through the maze and updates its policy according to, well, the better movements. So in the backtracking, we put ourselves in the goal position and sets that as our current position. And then we look in all directions from the current position. And for each direction, we also iterate through the entire route. From the end position, we only come from one direction or from one earlier cell. But later in the maze, we can come from several directions, so the minion can jump back and forth 20 times before going to the next cell. So therefore, we iterate through the entire route to see if the minion has been to the cell in the direction it's looking, if it has been to that cell earlier or several times. So if it has been to that cell earlier and maybe several times, we also look if that particular time or occasion, if that cell, if the action from that cell is pointing towards the current position. If it points to another direction and goes away in the wrong direction in the maze, then it's not interesting to remember that cell. So only if it points to the current cell, then we append it to a list, which we will look through down here. And we do that for all 4 directions from the current cell. And then if we have multiple possibilities to move in the backtracking, then, well, what we do is we take the cell with the smallest distance from the start, because that's the best way back. So we take that and then we update the policy for that particular cell. So the probability to go in the right direction next time increases with the learning rate we have set in the code. And then we normalize the policy. We then move to that cell, and then it all starts over, looking all directions and so forth, until we have come to the start position, because then we have a full route. We have the reset, add a new policy, and see if the maze is solved. But also this is the same as in the GA. We have the fitness function that doesn't do anything particular other than give us the score of the current minion. We generate the policy, a couple of variables, a couple of new variables from last time. And then we create a minion, set loose the minion in the maze, let it run back and forth, and if it's done, it then appends the last position also. And in this time we don't do generations, we don't have multiple minions. Instead we have one minion that updates its own mind or policy with the best actions for each position. And we have the update function up in the minion, and when the minion has solved the maze, when it's done, it then updates its policy, and then the minion gets reset to the start position, but with the updated policy, so the updated brain, so to say. And then nothing special, we print out a little data about the maze, and in the end some data about I will show you about the steps. And so we have the maze, and we start with, I set the cap of 1,000 steps, so in the beginning it goes a little slow because it gets capped off at 1,000, but then here it starts to find a route, but then again it gets capped off. But here it updated its policy with increasing the policy to go in the better direction. So when it once has started to find a better direction, then it will start to find the same direction multiple times. And here it has found a direction, or the probabilities have been updated and increased, so it will no longer be capped off at 1,000. And then it will update the policy every time, and it will drop quite fast. And this particular round I set my learning rate to 2%. So the step count or the distance drops quite fast. Here we have the fitness value. And we can see that here we get the first ultimate route with a step distance of 64 and the score of 1. And then it gets ultimate routes more often because the policy gets updated, and the probabilities to go in the best direction gets even higher each time. So in the end it will get a couple of outliers there, but then in the end it will have only ultimate routes. And down here we can see the route it took, which was the best or the only route. We can also see the fitness going slow in the beginning, and then zhoof, going up quite fast. And then we have a couple of drop downs, but still at 1 in the end. And we also have the distance taken. It gets capped off at 1,000, drops once, and then quite fast drops down. When it starts to get the right route, then it drops quite fast, and then gets steady at, well, the ultimate distance. Okay, I think that was all. Thanks for me, and have a good day. Bye.